Okay, let's get started. You all doing all right today? We have a test on Tuesday, right? We have a test on Tuesday. So we're going to finish up 10.7 today. I'm going to do examples of word problems. So the plan is for me to do one, and then I'm going to give you one to do. And then I do one, and then you do one. All right, let's just see how that goes. Hopefully we'll have enough time at the end to discuss the test in detail. If I can't discuss the test in detail, then I plan on sending out an email probably later today or tomorrow that will give more detail on what you should study. All right? So we'll talk about that later. Let me try and kill the lights just a little bit. Let's see here. Is that all right? Okay. We are going to be doing cost analysis. Again, this is Chapter 10, Section 7. The title of this section is Marginal Analysis in Business and Economics. So look at this first question. A company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by the following function. All right, so I'm going to write that function down here because I'm going to take all this off the board here in a second. 10,000 plus 90x minus 0.05x squared. Okay. So part A is to find the marginal cost function. So y'all remember what I told you to think about when you see the word marginal? Derivative, all right? So basically this is just asking you to find the derivative of the first function, or of this function. Let's see if we can't just kind of write down what we're going to do for each one of these. We're going to find C prime of x, right? That's what we're going to do for part A. For part B, it says find the marginal cost at a production level of 500 tanks per week. What does that mean we need to do? See, because part A just gives us a function, right? It's the derivative of this. Part B is asking us to actually find the exact marginal cost at a specific production level of 500 tanks. So they're giving us an actual X value, aren't they? And so they want us to do what? Plug that into the derivative, right? Not into the original function, but into the derivative. They want us to plug in 500. And then it says, part C, interpret the results. So we basically need to do, in words, we need to explain what the result means, all right? And then it says, find the exact cost of producing the 501st tank or item. So I put some formulas over here that we had, I think 2 classes ago. I gave us a bunch of formulas. And one of them is for exact cost. The exact cost of creating the x plus 1 item is C of x plus 1 minus C of x. So what we're going to do here for this one is what? If we want to find the cost of making the 501st tank, we are going to take, no? If we're trying to create or find the cost of the x plus 1 item, so that's like our 501st, then we will take the 501st cost and subtract the 500 cost. So we're trying to figure out if we make 500 tanks, this will tell us how much it costs, right? If we make 501 tanks, this will tell us how much it costs. I'm trying to figure out the exact cost of making just that 501st tank. So I need to take the cost at 501 and subtract from it the cost at 500. The difference between those two is going to give us the exact cost of making that 501st tank. Yes? Okay, notice these are not derivatives, right? These are not derivatives. This is a derivative, this is a derivative. We're going to explain what the answers mean, and then this is, we don't use the derivative at all for this. Okay? All right, so that's the attack that I'm going to have here. Let's go ahead and work through this. All right, so for the part A, we want marginal cost. Function. And that means the derivative. So what is the derivative of this function? Let me see here. I'll call on you. How about that? So make sure you know what it is. I'm going to call on somebody. Each one, lucky 20. Junior's not here again, huh? Okay. Jacob Barrera? All right, Jacob. You are up. So what is the derivative of C of x? Yep, go ahead.
It's
90? Okay, so derivative of that was 0, right? So 90. That's all right, you don't need to say 0, that's all right. 90 minus 0.1x. That. Okay, so you have to bring the 2 down, multiply it here. If you need your calculator for that, do that. And then reduce the power. So that's it right there, right? Okay. All right. Next part. Derek. So what are we going to do, Derek, for part for part 2. We want to find marginal cost what did the word problem say? Find the marginal cost at a production level of 500 tanks. At production level of 500 tanks. So what are we going to do there?
Would you solve for x, correct? What using the C prime formula?
Okay.
Next question into the next.
And so you're going to use this, and what are you going to do with it?
Replace the C prime of x with 500.
Okay, so replace this x with 500. Is that what you? Yes. Okay, good. So we're going to do C prime of 500 means we're going to do 90 minus 0.1 times 500. All right. What do we get here? 90 minus 50 equals 40. Right. So I put $40. Hold on. I didn't mean to put dollars. I meant to wait on that. Hold on. 40. All right. Any questions there? All right. Part C is to interpret the results. Interpret these results from part B. So for part C, do we have any idea what this number 40 means?
When you make 500, it costs $40 per unit.
Okay, so if we make 500 tanks, let me write that down. Let's see if we all agree with this. If we produce 500 tanks, then you said the cost
Would be 40 per unit.
is $40 per unit. Okay, I'm asking whether or not we all agree on this. So this would mean that the way I interpret that is that if we make 500 units, right? We're saying here that it's costing us $40 per unit to make 500 units. Okay? Is that what this marginal cost is actually telling us? So let me go back to a graph. The original cost function right here is a parabola, right? And it opens which way? It opens down, right? So it actually does something like this. Okay, that's our C of x. At 500 units, right? At 500 units, I'm getting a particular cost, aren't I? How could I figure out what the cost is of making 500 units? How could I figure that out? Plug 500 into this, right? And that would give me the cost. Let me do that real quick, because we really need to be able to interpret this 40 and understand what it means. This is a little bit off, okay? So I'm going to take, but I appreciate you at least going for it, all right? 10,000 plus 90 times 500 minus 0.05 times 500 squared. I get 42,500. Okay, so if we produce 500 tanks, it will cost our company $42,500, right? How much is that per tank? So how could I figure out how much that is per tank? Take this 42,500 and divide it by 500, right? So take that, divide it by 500, and I'm getting what? 85. It costs me $85 per tank to do it that way. See, I think the way that you said, and you may not have meant it this way, This is saying that it cost me $40 per tank, right? But just doing the calculation, this divided by this, it's actually $85 per tank. So that 40 means something different. Anyone have another idea of what that 40 means? It's not the cost per tank. Okay, so let's go back and look at it this way. What does the derivative visually on our graph represent? The slope of the tangent line, right? So if I go to 500 and I go and I take the slope of this tangent line, what is the slope of that line at 500? 40, right? Now my picture sucks, okay? It doesn't look like that slope is 40. It should be really steep, right? But it's 40. See, that slope of the tangent line is not giving you the average cost of like per tank. It's giving you something else. It has to do with how your cost is changing. See, the slope is telling me that as I continue my graph this way, my cost is actually going to be doing what? Rising, okay? So this 40 has something to do with the change in cost, not the average cost. So let's try and reword it. If we produce 500 tanks, then the cost is, right there we can change it. The cost is what? Increasing. By how much? $40 per tank. Tank. Okay. So what if we were going to try and foresee the future here? If I try and make that next tank, the 501st tank, how much should my total cost be? If we go to the 501st tank, what should it be? 42,540. Because it should be close to that, because this line is telling me, like the slope is telling me where that graph is headed. Understand? So I should anticipate that by making the next one, the 501st tank, my total cost is going to go up by $40. You see the difference between the wording in that? So the big thing that we need in there is that the cost is increasing. Understand? If that would have been a negative number, then we would have said what? It's decreasing by $40 per tank. And you would say decreasing, and you would put $40. You wouldn't put negative $40. You would put decreasing by $40. All right, we good? Okay. Now, part D, there was a part D, right? Part D is asking us find the exact cost of producing the 501st tank. I can't spell tank. Again, we need to understand the difference, like in this wording. They are not asking us for the total cost of making 501 tanks, right? If they wanted the total cost of making 501 tanks, we would just plug 501 into this, right? And that would give us the total cost. What they want is that cost of moving from the 500th tank to the 501st tank. But they want the exact cost. See, the marginal cost, this right here, gives us like an approximation. This is an approximation. We want the exact cost. So how do we find the exact cost? This formula here. So we're going to do what? C of 501 minus C of 500. Now I already found C of 500, didn't I? It was this. So I know that this is 42,500, but we need to find C of 501. So I'm going to get my calculator out. I'm going to plug 501 into this. And let's see what we get. Anybody have it? Remember, you want to be using your calculators so that on Tuesday when you come to take your test isn't the first day that you're trying to use your calculator, because I won't have any sympathy on you. And also remember to bring your calculators, because I don't have extras to hand out. And you may not use your phone. So that would be a pretty bad thing if you came without a calculator on Tuesday. All right, so what do we get? Anyone get $42,539.95? Okay. And now if you subtract these two, you should get $39.95. And that's dollars. So it cost us, from moving from 500 tanks to 501 tanks, the change in the total cost for our company changed by $39.95. It went up by that much, yes. You shouldn't have any rounding problems here. It should have been an exact answer. What did you get? Let me see. Your calculator. Oh, wait. Oh, did you ever subtract? No. Did you subtract the 42? Well, I don't.
No, I didn't subtract 42, but that answer is already just rounded.
Yeah, I'll have to look at your calculator. That should not have rounded that. Your calculator might be set to round or something. Yeah, no, I need $39.95, not 40. For this answer. So let's try and recap here. Was our marginal cost pretty close to the true exact cost? Yes? It was off a little bit, but marginal costs are approximations, so it could be that we're a little off. We had this formula I gave you last time. C prime of x is approximately equal to c of x plus 1 minus c of x. Okay, so that's exactly what we just determined. We determined that marginal cost at 500 was pretty darn close to C of 501 minus C of 500. Okay? You ready to do one on your own? There you go. I'm going to give you 10 minutes because, I should probably erase all that junk. I'm going to give you 10 minutes because you're going to have several of these on a test in a few days. So time is important here, that you can get through this quickly. And right now you can refer to your notes. On Tuesday you can't, right? So you need to make sure that I will provide you the formulas, all right? I will provide you these formulas, and we can talk more about that at the end, but so 10 minutes. If you need a hand, if you need help, raise your hand, I'll come by. If you finished it, raise your hand. I'm just going to come by and check it. Where you at? Good. Okay, that looks good. Who else? Are you done? Doing that? 200. What does it say? 200. Okay. Then what is that? Is increasing by $300 per.
Car.
Well, it's actually transmission, but that's all right. It's car, and then yeah. So just work on that wording of that part C. Okay. Yes, good. Who else? All right, you can check with her.
Oh, no, I.
Oh, you have a question?
Yes.
Okay. All right.
I keep messing up when I'm typing this into the calculator.
Okay. So if you're going to do that, I suggest that you do them just one at a time. So this,
Okay.
Do this first, write it down. Like do that. You'll leave that alone. Then do this first.
Okay.
So do 600 times 501. And then you'll have to write that down, and then you're going to have to do this for each one. And when you get to this one, square this first, okay, and then multiply times this.
All right.
All right? And write them down, and I'll come back and check and see if you got them. I'm just going to check one person at each table, and then y'all can. If we produce 200, then the cost is increasing $300 per. Be careful here. This is per unit, okay? Per transmission. All right? And then everything else is good. So y'all can check off of his wording on everything there. Over here? Anyone here yet? Let me see. 300, if we produce 200, and the cost is increasing by 300 per transmission. Yes, that's good. Let's see.
The one I was confused about was this one. Would I do that minus that?
Mm-hmm.
But so it would end up a negative number though?
No, it should be positive.
Okay.
Yeah, you have to, when you type it in, just make sure you type it in all. You're plugging in 201 and 200 into the original function,
Oh, the
not to the,
original-
not to the
okay.
derivative.
Okay.
All right?
Thank you.
You got it here? Where are we at? Okay, 300, if we produce 200 per week, the cost is increasing per transmission. That's right. So y'all look off each other's there. Make sure, because your wording is perfect on that, so your wording has to match up to that. Okay, you still working, or?
Yeah, I have a question.
Okay.
When I when I do the 200, I put it into here, right?
For what? For what part?
For the part where we're figuring out how much the supply would, or how much each tank would be. Do we need to find that?
You don't need to find. I was trying to
Okay.
explain. I was trying to explain why the wording has to be a certain way.
But either way, I have to get this cost, right?
You do on this part right here. On part D, you have to take the cost at 201 and subtract it from the cost at 200.
So I would just subtract the 201 or the 200 into this formula, right?
Yeah, go back, flip to it. You're gonna plug 201 into here, and then subtract from that 200 into there.
Okay.
Okay. Did y'all get it here?
Yeah.
Yes. Let's see, we produce 200 transmissions, and the cost increasing. Okay, that's right. Okay, I think that's enough of everyone that we can move on, because we do want to leave ourselves a little bit of time at the end. Okay, let's look at the next question. Okay, look at this one here. Exact cost and marginal cost, same two ideas, all right? Find the exact cost of producing the 121st bicycle. Okay, so you got this function, it's the cost of producing X bicycles, there it is. So what is part A, and I'm going to call on somebody, what is part A asking us for? And I am calling on, let's see, 2019. It's Nicholas. Where's Nicholas? Okay, Nicholas. So do you know what part A is asking us for? Like what are we going to need to calculate? Go ahead.
It's asking for the difference of price between the 121st bicycle and the 120th bicycle.
Yes.
So we go ahead and set 121 x in the first part of the equation.
Into the original function right there, right? Okay.
And then you set at 100, the 120th, or 120 as x in the second part of the equation.
And subtract. So that's what it's asking for. So what tells us that we're using this is the fact that you see the word exact in there. When you see exact, then you're going to use that formula right there. Whatever item that they're telling you, 121st, you put that in, then you subtract 1 from that, 120, and you take the difference between those into the original function. No derivatives at all in this part of the problem. Okay? Now, this next one's a little tricky. And yeah, is this thing... Okay, there we go. Armando. Who's Armando? Okay, Armando. This one's a little tricky. Use marginal cost to approximate. So, approximate, marginal, right? Marginal is making you think what? When you see the word marginal, you're going to be thinking,
Marginal cost?
yes, but I want marginal in your mind to set off like a light bulb. And I want you to think derivative, okay? Okay, this means you're going to be working with the derivative of the function. And what you need to do is find the derivative at what? Of producing the 121st bicycle, right? So what does that mean? We're going to find the derivative of this?
Yes.
Okay. Okay, so this, remember I said this one's a little tricky? This one's a little tricky? Okay, let me go back to a picture for you. Maybe the picture will help. Okay, if we have a function, and I'm going to kind of exaggerate it here. If we have a function that does something, and let's say we have 121 right here. This is our cost function. Right? Then if I would like to know the cost of making that exact cost of making that 121st item, I'm going to take the cost at 121 and subtract 120, right? So I'm coming back here to 120, and I'm trying to find the difference of these heights, right? These differences. The difference of these heights is that calculation, right? And that would be the cost the cost of producing that 121st item. Yes? Okay. In part B of this one, it wants us to use the marginal cost function, the derivative, to do the same thing. So we do not want, for part B, we do not want to be doing C prime of 121. We do not. Why? See why I'm saying it's a little confusing? Because doesn't C prime of 121 give me the slope of this tangent line right here? Right there? And isn't that predicting what's going to be happening later? Yes? So I actually need to come back to 120, and that will predict what's going to happen at 121. That's the tricky part of this. So this part B needs to be not C prime of 121, but C prime of 120. See, I'm trying to foresee what's going to happen at 121. So I go step one back to 120, and then I use the derivative to try and figure out where I'm going to land at 121. Now, I understand that that's confusing. That's why I'm trying to to really stress it. Let us go back, look at the word problem again, and look at the wording. On the first one, finding the exact cost of producing 101st to 21st bicycle, we just go take C of 121 minus C of 120. We're done. This one, I'm saying it says 121st, but you need to do C prime of 120. What about the previous problem? Did we do that wrong? Well, let's look at this one. They tell us, find the marginal cost at a production level of 500. They're telling us, at this production level, what is the slope of the tangent line? That's what this is asking us. Find the marginal cost at that production level. This problem that we just did, or that we're about to do, the wording is a little different. It says, find the, or use the marginal cost, right? Use the marginal cost, not find the marginal cost. Use the marginal cost to approximate the cost of producing the 121st bicycle. Do you see how that wording is different? That means you're going to have to understand on the test that you need to take one step back and go to 120 and take the derivative. Are we good? Okay, I'm not going to work through this one on the board. I'm just going to show you the solution to it. So for part A, what we had to do was C of 121 minus C of 120. So you plug 121 into the original function, you plug 120 into the original function, get the two answers, subtract them, you get 108.80. All right? On part B, you're going to, again, take that step back and you're going to try and figure out the derivative. So I'm assuming you can take the derivative of that function and then plug 120 into it and you get 102. And so you can see the difference between the exact and the approximation is pretty close. Understand? All right, why don't you do this one on your own? Can y'all read that okay? Talking about this one right here, match problem 2. So go ahead. I'll give you a few minutes. Yes. You need the function? Yeah, let me see if, I'm going to write it down. It's the same one. There it is. So I'll jot it down, then I'll scroll back down. It's 10,000 plus 150x minus 0.2x squared. All right, can y'all see it okay over there? All right. I'm going to give you 5 minutes on this one. got it? Carlos, you got it? I'm just messing with you. Yeah, okay. Good. Who else has it? Yes, good. Yep. No issues? You're good? Yep. Okay. How about over here, guys? Y'all got it? 9380 and 94, right? 9380. Are you having trouble getting it, or
Oh no, I got
Yeah.
93.4.
0.84?
No, 93.
0.8? No, 93.4? Let's see. Let me go up here. Did you ever subtract?
I did. Yeah, I subtracted right there. I got the answer of the first one. So I just.
Yeah, that
I
looks
just
all
made
right.
42 plus one
Ah.
over here.
Yeah. Wait, why did you do 42?
Because it would be plus one, wouldn't it?
No.
So it would be the whole. Wouldn't it be all the x's on the first side plus one?
No, you're actually going backwards one. Are you talking about that first formula over there?
Yeah.
Okay, so notice in the first formula, it's saying that if you're trying to find the exact cost of x plus 1, then you're going to do that x plus 1 and then just x. So if this was 141, this is 141 and this is 140. See, this is one less than that.
Okay, so you're using one.
We want to know the exact cost of 141, right? So we're going to do the cost at 141 minus the cost at 140. We're not going to do the cost at 142 minus 141. That would give us the cost of making the 142nd bicycle, because we're going from 141 to 142. We want to actually go from 140 to 141.
Okay.
Yeah?
Gotcha.
Okay. Okay. All right, we good? Let's move on. All right, let's look at another one. Okay, this one's going to be more complicated. Production strategy. A company's market research department recommends the manufacture and marketing of a new headphone set for a MP3 player. What's that? Do they even make MP3 players anymore? I have a couple of old ones. So the book's a little dated. For an MP3 player, right? For MP3 players. After suitable test marketing, the research department presents the following price-demand equation. So this is something you did in 1324. This is price-demand. So this is the equation. X is the demand at a certain price. So if this company decides to make the price of their MP3 players $1, okay? If the price is $1, we're going to have a demand of 10,000 minus 1,000. We're going to have a demand of 9,000 MP3 players. All right? If we make the price $2, then it'll be 2 times this, right? Which is 2,000, and then that would subtract. We'd have less demand, wouldn't we? And if we make the price too high, our demand's going to eventually be 0, won't it? Okay. Is that the end? Hold on. Yeah, that was the end. I have to go to the next page. Trying to get to the question here. Where the heck's the question? Here we go. Let's just continue reading through this. In the price-demand equation, which was x equals 10,000 minus 1,000 p, all right? In that equation, we could solve this for p, couldn't we? So let's say we solve this for p. How would we do that? Well, I want to get p by itself here. I could move the 10,000 over, subtract 10,000 on both sides, and I'd have negative 1,000 p, and then what would I have to do? Divide both sides by negative 1,000. So if I divide this by negative 1,000, divide that by negative 1,000, and then divide the 1 that's out in front of that by negative 1,000, then what you would get is this right here, okay? Negative 10,000 divided by 1,000 is 10. 1 divided by negative 1,000 would give you negative 0.0001x. Understand? Y'all sure? Okay, so this equation comes from the original price-demand equation that was given to us. The difference now is that we can determine the price, what we need the price to be at a certain demand. So if we want the demand to be 100 MP3 players, this will help us establish what the price needs to be. Understand? So we've like flipped the roles of the variables. Meanwhile, our financial department has determined the cost function for our company. This is how much it's going to cost us to manufacture X number of MP3 players. Right? So we got two things going on here. We've got our research team discovered price-demand equation, and then our financial people said, hey, look, this is how much it's going to cost to pay our employees to turn the electricity on, right, to buy the materials. This is how much it's going to cost us per MP3 player. Right? So if we don't make any, it's going to still cost us $7,000. Right? If we make one of them, it's going to cost $7,002. Got all this? We haven't even got to the questions yet. Here they are. Okay. Find the domain of the function defined by the price-demand equation. All right, so that means go back and look at, well, let's just do that one first, all right? We want the domain of the price-demand equation. And the price-demand equation was this one. So this is part A. Price was equal to 10 plus, or no, it was minus 0.001x, right? Now, what do we know about the price of our MP3 players? They have to be greater than 0, right? I mean, we're not going to have a negative price, are we? We're not going to pay someone to come take the MP3 players out of our warehouse. Maybe. Might be hard to get rid of them. It's like trying to get rid of VHS tapes, right? All right, so we know, when we say domain, what we're saying is, do we have any restrictions on what this x can be? You know? Like, is it possible to have that x be negative? Or, you know, like, what are the restrictions? So all we do is we start with the idea that the price must be greater than 0. Let's go with that. All right? Price must be greater than 0. Agreed? And that means that 10 minus 0.001x must be greater than 0. And then I can start moving things around. Why don't I move this to the other side of the inequality? And when I move it, it becomes positive, doesn't it? When I move it to the right side, it becomes positive. And now, how should I get rid of that 0.001 in front of the x? Divide both sides. So if I divide this side by 0.001 and divide this side by 0.001, what do I get? $10,000, right? This is going to be 10,000. So our x must be smaller than 10,000. What is x again? The demand for MP3 players. So I know that my demand, in order to keep my price as a positive number, I need my demand to be less than 10,000. Now, can you tell me anything else about that demand? Could it be negative? Can you have negative demand? Well, I guess you could, right? But no, you can't have negative demand. So it'd also have to be greater than 0, wouldn't it? So that's where we get our domain from. Our x must be greater than or equal to 0 and less than, you can say less than or equal to It doesn't hurt to put equal here, but if we put equal, then our price is going to be 0. Like we're going to be giving them away. So it doesn't make a whole lot of sense. This is our domain. Understand? Domain, right there. The demand has to be between 0 and 10,000 for us to have a reasonable price set for our MP3 players. That's part A. Let's talk about part B. For part B, find and interpret the marginal cost function. All right, so we were given the cost function already, weren't we? We were given that cost function? Maybe I should have wrote it down. Let me write it down on the side over here for us. It's a pretty simple cost function, isn't it? Part B. Find and interpret the marginal cost function. So for part B, what is it that they want us to do? Find the derivative. Okay, and then explain what it means. So what is C prime of x? 2. And that's just 2, right? That means the marginal cost is always 2. Right? No matter what. It never changes. Like x is not in that answer. So that means that the cost is doing what? Is increasing by $2 per MP3 player always. I put that in there at the end. That means that no matter what, as we start selling or producing more of these, right, our cost just keeps going up by 2 each time. It's not like the last problem where it was changing as time went on, the cost of producing the next one. That okay for part B? All right. Part C. Find, and this is something new, we have not talked about this. Find the revenue function as a function of x and find its domain. The revenue function. Revenue is how much you're going to bring in, right? How much you're going to bring in. So let's try and find the revenue function. So to find the revenue function, do you remember what revenue is? Well, think about revenue, okay? Revenue, we're going to look at it as a function of x. Think about this company, right? You're going to sell these MP3 players, right? How many are you going to sell? We don't know, right? But we can say X of them, right? We're going to sell X of them. And how much are we going to sell each one for?
X dollars.
How much?
X dollars.
Well, X can't be both how many we sell and its price, right? So I'm sitting here, I've got an MP3 player, right? I'm going to sell this. The number of them that I sell is X. How much money I'm going to bring in is going to be how many of these I sell times the price of each one of these, right? So isn't the revenue going to be X times P? How many I sell, or you could even say the demand for them, right, is X, and then times P, which is the price. Understand where these come from? Do we know what the price is?
Yeah.
We do. We actually have it written down. We found the domain of it a second ago. Wasn't the price 10 minus 0.001x? Wasn't that price a second ago? See, our research department was able to provide us the price demand equation. And using that and multiplying it times how many we sell will give us our revenue function. Understand this? That means our revenue function is actually 10x minus 0.001x squared. So all I did was distributed the x through the parentheses, and we now have a nice little revenue function. Now, Part C also asks for the domain of this. But the domain is going to be exactly the same as the domain of our price-demand equation, right? We said that x had to be between 0 and 10,000. Well, our revenue can't be something different than that because our price is based upon this also, right? So you just copy that from the first part there and bring it down. Y'all still with me? I'm running out of time here. So we have answered, I believe we have answered part C. Now part D. Find the marginal revenue at 2,000, 5,000, and 7,000. Find the, what does this word mean again? When you see this? Derivative, right? Okay. So find the derivative of the revenue at these three values. So for part D, they want, for part D, they want us to take our revenue function, which we just said was 10x minus 0.001x squared, right? That's our revenue function. They want the marginal revenue at 2,000, 5,000,